Who am I? Why am I here? Okay, well, what we're going to go ahead and do is try a test stream out here on game programming in C using the SDL2 library. Now, the SDL2 library is a library that doesn't actually, I don't want to say it doesn't do a whole lot. It does a lot under the hood, but it is the simple direct media layer. It doesn't do much for you. It just basically gives you a buffer that you can render to. It lets you handle input, and it lets you render using the native backend of your platform. It's cross-platform. You can use fonts, sounds, things like that. In other words, it's the kind of thing that is quite helpful to help you write an engine, a game engine, without some of the really mundane, inane, boring boilerplate that you'd often have to do. But it also, it doesn't do anything for you over and above just giving you buffers to work with for rendering stuff and putting it on the screen, handling input, handling sound, etc. It doesn't help you to draw things. It doesn't help you to move things around the screen. You have to do all that yourself. And so, although it's super useful in the one sense, it's also it's also amazing how much you need to do. Don't think that it's a game engine. It's not. But we are trying to go ahead and write a game engine. Thankfully, I've already started a lot of the work that needs to be done. And this is a sprite sheet based game engine. So why don't we actually start by just let me show you the sprite sheets that we're working with here. So if I go to Git sprite sheet game engine, you're going to see a lot of stuff here. I'll make clean so that we only see the source code and not the .o object files. The assets are tremendous assets that I took from a couple of sources. They're all free. I'm not using them illegally or anything like that. They're super cute. Let me check. So we've got these assets here, which are from a roguelike pack. And if I could make this larger, I will. Yeah. All right. Let me try to make it larger again. There we go. So we have these tiles. They're 16 by 16 tiles. They're all 1 pixel apart. So I had to include in the engine, as it's been written thus far, a way to handle the fact that there's margins. So that's fine. But you see, you got a lot of what you need. You got water, you've got grass, dirt, trees, beds, dressers, doors, treasure chests, tents, like all the stuff that you need. And you've got some dungeon assets as well. If you want to, we're definitely going to want to do some dungeons later on. That's all good. So that's cool. So we've got that guy. And if we open, I don't want to actually. I don't want anybody to see confidential files I have on my computer. So if we go back to the assets folder here, we've also got these really cute sprites. Let's see here. Make them a little larger. You've got these sprite sheets that, again, I got for free online. I'm legally allowed to use them. These are called, I think, puny characters. They're super cute. You've got this soldier guy. You see some of the walking animations around here, sword slashing animation, etc., etc. These are all 32 by 32. No margins between them. It's a little hard to see because you got the transparent background. But the way that the guy described them that made these assets said, oh, well, they're 32 by 32, but they fit in a 16 by 16 space. That's not really true. What he meant to say was the images themselves are 32 by 32 with a lot of transparency around the background, but the hitbox of them can fit within 16 by 16 pixels. So working around the way these sprite sheets work, I programmed it into the engine as it is thus far, and we'll see it in a moment. Being able to choose your hitbox and where that is located. And so what we do is we basically peg it to this 16 by 16 range in this section of the sprite. And so anything else gets rendered, but is not, it's rendered visually on the screen, but it's not considered in any way for, like, as part of the tile, if that makes sense. Because it is going to be a tile-based game engine. Oh, I see. Weird. What happened here? No. Oh, all right. Sorry, I wrote this image editor myself, and so it's a little bit buggy. It's not 100% perfect. I thought that I could open up another file with it, and it would open the same instance of the application. That's a bug I think I need to work out on this program. But anyway, here we go. Here are some of the assets that I've downloaded. I like this slime monster. It's super cute. You've got this archer guy. I think is really cute as well. And I would definitely like to use the archer at some point. We don't use him yet, but we will. Oh my gosh. Wow. I do not know what I'm doing with my own program. Let's see. Let's restore this. How do we do this again? To the original size. There. Let's set this to scaling mode. Okay. That's a little bit easier to see. You got these animations. Again, same concept applies as before. So we want to work with these sprite sheets, okay? And we want to be able to make a game with them. So let's see what we have thus far. So if I go into the source directory and the source code, I think what I'll do is, if I post it in the chat, I'm not sure if people will see it, but let's do that anyway. It's here on GitLab, LA Rathbone / sprite sheet game engine. I'll just post that in the chat. Can I pin this somehow? Oh yeah, I can. Right there. Pin this message. There we go. See, I'm really bad at Twitch. I don't understand the way that it works. Some of the design decisions of Twitch, I feel like, maybe make sense for people that do this a lot, but for me, I just stream every once in a while. I just find it very cumbersome. But that's the source code there. All right. Enough of my yakking. Why don't we just try this darn thing, and I'll be able to explain some of it better. make sure that we have got the build. Oh yeah, that's right, we made clean, so we had to make it again because it was not compiled anymore. So I'm running it in GDB, and you see thus far what we have. You got this guy can walk around the screen. You're going to see lots and lots of debugging information in the background. If I move this guy up here, it might make it easier to read. You got these slime sprites that are moving around. You see our player here. I'm moving up and down right now in case you can't see my mouse. And the treasure chest here and these two slimes are sprites. And so we've designed them to be sprites. Actually, the trees are also, this tree guy here, you see I'm walking around it right now, is also a sprite. The reason for that is because I'm still kind of working this thing out. I want this idea of, you got the map, which we're walking around the map right now. The flowers here, for example, is part of the map. The water here is part of the map. You can have a map and you can have collision data in that map. So you can't walk onto the water tiles, for example, but it's not a sprite. It's a background tile. And the flowers are background tiles that have no collision, as well as the grass, same thing. This water pond right here is also background tiles that have collision data attached to them. But we also have the concept of layers, and so we have the background layer, the player layer, and the foreground layer. We might change the name of that later on, but the tiles are part of the background layer. The player sprite is the player layer, and then you have the foreground layer, which will go in front of any player sprites that we have. And so this tree here is actually two sprites. So we have the bottom sprite, which is at the same level as the player, although it has collision data, so it doesn't actually matter at this stage what layer it's at, because you're going to collide with it anyway. But because this top part of the tree is the foreground layer, you can actually walk behind it, and you can see that the player sprite, relatively seamlessly goes behind the tree, and so it gives it that effect that we want. But just the test code that we have right now allows for us to swing a sword, and we can do that by hitting the shift key. It's hard coded at the moment, but changing that is trivial. And then that triggers an animation, which you cannot get out of until it's done. And at this stage, just as test code, you can see a lot of this debugging information appearing in the background. You can actually try to attack really any sprite that you like at this stage, because you got test code, and if you attack, for example, this treasure chest, it's going to blink like that to show that it's being attacked. You see we're getting a lot of error messages in the screen, because I think what's happening is the slimes are sort of going in and out of the camera, and some of the stuff was programmed to generate errors when it might not be necessary to print an error to the screen. It should probably just return silently. But you can't walk outside the border of the screen for the map, for instance. And you see these slimes are moving, right? Whereas our character's moving based upon our input. We have a system right now that I just implemented or started to implement last night called a move queue system, in which you create what's called a move queue, which is a list of directional inputs that a sprite can utilize. And if the sprite has a move queue associated with it, it will sequentially execute those movements. And so I just put a whole bunch of random ass movements for these two slimes are two separate sprites. They're not just copies of the same thing. I mean, they're copies of the same thing in the sense that they're using the same tile set. But as far as the program is concerned, they're different. And they have different move queues associated with them. But what's interesting is that I'm still working through this, but is that because of the way that we program this, the move cues respond to collision detection. And so if I've, you see these slimes right now moving left, up, etc. If the move cue told, for example, this slime right here to move up, like, oh, it crashed. Okay, well, we will. Good to know. We'll come back to that. But if the sprite move cue told it, for example, to move up right now, like where I'm standing, it wouldn't do it. It would just ignore that because of the collision detection. I'm almost happy in a way that I got that crash because I haven't really had very many crashes in the past few days, except when I've been implementing new things. So if I did a programmer error, I'm actually quite interested in that crash. I'll look into that. I'm not sure why that happened, but those are the kinds of things that I definitely don't want to be happening. So I'll have to look into that. But yeah, that's basically what we have so far. And you notice that the map scrolls with the player. That's fine. So a lot of the test code that we have right now is on a massive, well, not too massive, but compared to the standard of the other sizes of the files, a pretty big .c file called test.c. And you see it's at the upper corner. Here's the file name in the Vim tab. And how long is it? It is 1,600 lines approximately. So not huge, but getting pretty big. We're gonna want to break that up pretty soon. My concern when I was doing this thing was that I didn't want. The last time that I attempted to make an engine like this, I just made everything so broken up and so modular too early that I didn't even really know what I was doing yet. But I'd made everything, like if you look at the code, it's visually beautiful code, but it just doesn't work very well. And so I just kind of wanted to avoid that and keep the test code in one place for a while until I was sure what I was actually doing. Because I don't know, like I'm not a game programmer. I don't know really what I'm doing. I haven't done this really professionally in any capacity before. And I don't really know what some of the principles are. I'm just learning them as I go along. And so that was something I was trying to avoid. So for example, right, let's go to we have a massive function called test. And that's where the test code is really being inputted that creates the world that you actually see on the screen. And it utilizes the engine as we've written it thus far. And so you've got, right now I've just used static pointers for the tile sets, the map, the camera, and then sprites are sprite. That variable name is the player, really. And then you have the chest, the two slimes, the tree top, the tree bottom, and then eventually we'll talk about what the game state is. I'm not going to get into that right now, but basically these are all initialized to 0. So if one of them is initialized, then we know that then we can just skip all this initialization stuff. Again, this is test code, so I'm not really super concerned about what it looks like, but what I wanted to show is that the map camera has a concept called a follow sprite. And what that is if it is enabled, like if we define the follow sprite to be a thing, then what will happen is the camera will follow that sprite and it will scroll along with it. So right now we've got camera follow sprite is equal to sprite, which is the player. If we comment that out and rebuild and run it, you'll see that now we're not scrolling. The player is just moving along, but you can still interact with the environment in the same way. And I have to use the bathroom. I will be right back. You can admire these beautiful visuals for a moment while I take a break. back. Let's see. So, where were we here? Yeah, I was just showing the engine thus far. Oh yeah, I was showing you the non-scrolling mode. That's fine. Let's quit that. Let's re-enable the scroll. What we will eventually want to do is make it so that, if the position... let me take a step back. We don't have any concept yet of a window, of how big the window is, if it's full screen. Do we have a split screen mode going? That's something that I actually would like to enable. And in fact, I'm going to go to... This is the first attempt to make an engine similar to this. I sort of abandoned ship on it and started over, but used a lot of the same code because it was just getting. I made some decisions that I really didn't care for, but it was so modular and it was so well written that I just couldn't really. It was hard to back away from what I had written, but this is the first attempt at making something, and with this version. It does a two-player mode was started right from the word go, which was a mistake. I should have perfected some of the other aspects of it before going that far. But it's kind of cool because the arrow keys in this version, which I'll probably take some cues from the new version, but in this version. All the input controls are defined are configurable through an INI file. And right now, the way that we have it is this guy right here on the left is the first player, and he's controllable with the arrow keys. And this guy on the right is controllable through WASD on the keyboard. And what's really actually quite neat about this earlier version, and it doesn't really handle much else other than movement, but it has some collision detection. Is that if you move off the screen, like if this guy here, player 1, moves off the screen will actually split, and you can move in your own screen. And player 2, I guess, that was one of the flaws here. It should have partitioned the screen in the opposite order, but whatever. Player 2 can still move with the WASD keys. And the idea was meant to be, and it will be in the new version too, is that it'll be kind of a roguelike, but multiplayer, and so in real time. So you'll want to interact with your environment, find items, fight monsters, move to the next level of the dungeon, etc., etc., but working kind of together. And if you, as player 1, for example, on the right side, goes back to where player 2 is, the screens will merge again, and the players are on the same screen. But if Buddy goes down this way, you see then it's a little glitchy, but it's not working very well. What if I go this way, to the right? Will that work? Yeah, that works. You can even have them, going in different directions. That's all fine. So this earlier version has the concept of viewports, and where the viewports will be positioned on the screen. It can be split screened in 2 ways. I want to do that with the new version as well, but at this stage, there's no concept really of where that camera is going to go. It's always in the upper left-hand corner. It's just rendered there. But in this version, we have a camera that can be defined to be a certain size. So if I actually maximize this window, the camera right now, width and height are hard-coded just for testing purposes. And so you can actually see as I move, darn, I forgot to recompile with the follow sprite re-enabled. So let's do that. Right, so let's maximize it. You're going to actually see these tiles, the tile, the next tile over from the size of the camera, getting rendered on the right-hand column in advance, and you can actually see that happening. It's almost like an old Nintendo game where they assumed that the right-hand side of the TV would be cut off, and so you wouldn't see that happening. It's kind of a similar concept here, really, as to what's happening here. But it's always one larger, the margin around the side, and you can define that to be whatever you like. But right now it's always one larger than the camera size itself. So the idea is that as we resize the screen later on, the camera will adapt, the camera size will adapt to the screen size, and it'll always be one larger than that anyway. And so this stuff that you're seeing on the artifacts you're seeing on the right hand side won't happen. But just so you can see what's happening behind the scenes, that's how it works. So that's fine. So why don't we look into the structure of the code a little bit? So why don't we start from the beginning? And by the beginning, I don't mean the makefile. I'm not really too interested in that. Let's take a look at main.c. You see, it's dirt simple. All we do is have a couple of pound includes, being the game state and the main loop, and then we take the arguments of the argc and the argv, but we don't handle them in any way. And then we use an auto pointer to create the game state, and then we just run the main loop based upon that game state, and that's it. That's all we're doing in the main.c file. So it sort of raises the question, well, what's the game state? Because that's the variable that we're creating here. And also, what's the main loop run? Because that's the function that we're calling here. And so let's take a look at the game state first. Let's make that a bit bigger. There we go. So let's look at the header file first. So we define, remember, this is all C, not C++, and so we can't just say struct game state and have it known that that's what you mean when you say game state. You have to say type def struct. I could go type def struct, delete that, and then just put game state here, and then just not even include this line here. But the problem with that is that there are times when you want to be able to refer to the struct without saying the words, without saying the token, or without saying the the C language keyword struct before you've actually defined it. And so if you just always write it this way, you're not going to have that problem later on. And so I just tend to get into the habit of doing that. It's a bit repetitious, and that's, but that repetition of repeating the word game state 3 times is really nothing in terms of the annoyances of working with writing a game engine. It's really not a big deal. There's a lot of other things that are way more annoying than that. And so we sort of, this is a good way of showing the format that we follow. Again, we have a very rudimentary object system. We're using glib2, which is the library, as well as SDL. The only 2 libraries required right now are SDL2 and glib2, glib2. And we're doing this on Linux, but it should be cross-platform as long as you can get glib2 and SDL2 to run on Win32, which I think is actually pretty easy to do. So we have basically a namespace, which is game state spelled this way for the actual class or struct type, and then game underscore state for the functions that go along with it. So we're going to have game state new to create a new object of type game state, and it takes no parameters. And then we're using underscore destroy, kind of like the way that we're using underscore new as our suffix, whereas here we're using it as our prefix for like our constructor and destructor functions, essentially. And what we have down here is really nice. We're using gdefine auto pointer cleanup function, and what it's a macro, and it takes the struct name and then the struct destructor function as its two arguments. And so what that means is, here, when we go ahead and say g auto pointer game state is equal to game state new, we don't have to free it. I mean, in fairness, it would just be freed upon exit, so it's not that big of a deal in this instance. But it really does save a lot of typing, because we don't have to go, like, for example, game state star state is equal to game state new, and then return. Well, you'd have to do something like, int ret val, and then go ret val is equal to main loop run. Get rid of the GSTL pointer here, and then game state destroy state, and then return ret val. Like, it's fine, but in my view, it's easier just to do it in one fell swoop this way. And what happens is, at the end of the scope of this function here, game state will be freed automatically by the compiler using this auto pointer cleanup function that we defined here. So that's pretty nice. But if if we use GSTL pointer, you see, actually, this is actually not necessary the way that I've done this here. If you put GSTL pointer here, it'll actually nullify this variable, and then it will not free it at the end of the block. I think the reason why I use it here is it's the same reason why I do it in a lot of other places, because let's say I add a whole bunch of code in here, and then somewhere in here, if not ASDF, fatal error, blah, 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 then the program will exit, but the game state will also be freed. And so that's kind of nice. Not the best example, I guess you could say, but that's the way that it works. And so that's all fine. The game state has a bunch of basic members in it. You basically have an infinite loop running until you provide a quit request to be true, and then if it receives that quit request, the game state will tell the program to exit. I mean, that's not atypical with SDL2 types of things. So that's fine. So that's how the game state works. What happens if I take a look? Oh, the main loop is already the main loop.c file is a bit messy. I'm not sure if messy is the right word, but it's incomplete presently. The original way that I had it was that I made main loop an actual object, and then I had main loop run, and I took the main loop object as a parameter. But I thought, what's the point? Like, it's not. There's no point. And so I just made main loop be a series of functions. And what I did was you pass the game state to it, and then it sets a static global called state with capital letters to be a global game state, because you're never going to have more than one game state for the game. And so that's really the only, it's not a true global variable in that sense, but it's a static global variable, meaning it's global, but just for the main loop.c file, a translation unit. But I'm pretty sure, I think it might be the only global variable in the whole program. And that's fine. That's pretty, if you have one global variable for a game, and that's the game state, you're not really doing too poorly. But what you can do is, you can call main loop get game state at any time, and it will return the global game state to anywhere in the program. So it's not a true global, as I said, in that sense. But if you call main loop get game state with no parameters, not any object at all, it will return the global state to you. But you have to be within, the main loop has to be running for that to work, otherwise it'll give you a fatal error. So that's fine. A data type that we use all throughout the program is a vector, and it's a 2D game, so we have a 2D vector, and it's a 2D tile-based game, so we have a 2D tile-based vector that we're using all throughout the game. Turns out, after I started writing this, that SDL2 comes with basically the equivalent of a 2D vector called an SDL point, which has an x and a y coordinate in one structure. And I didn't really realize that until more recently. So I probably could have just used that data structure and standardized on it. But my vector2 class, or whatever you want to call it, my vector2 data structure is kind of nice because it's defined as a union, so you can access it either as an array, or you can access it as a struct with the x and the y coordinates accessible there. And you've got your functions here that will, if you want to, create a vector on the heap and destroy a heap allocated vector. And you can copy again a heap allocated vector, and then you destroy it, and it has an auto pointer cleanup function as well. But what we use a lot throughout the program is the add and subtract functions and the multiply functions, or the multiply function is actually a macro, but close enough. Which what it does is it takes by value for the add function, for example, two vectors and adds them together, and you can also subtract two vectors as well. So this is pretty nice because any direction in the game can be defined as a one-step vector in that direction. So a static vector is just nothing's happening. It's a 0 and a 0 for x and y. But an up vector means we subtract the y-axis by 1. The down means we add 1 to it. Left is the x-axis is shifted over by 1. And the right is it's shifted over by 1 in that direction. And so we have some pound defines that are defined as compound literals that provide x and y vectors simultaneously on the stack to functions that we're dealing with. So that's pretty nice. It doesn't seem obvious at the beginning why you'd want to do that, but when you start to deal with things, when things start to stack up, and you start using the addition, the subtraction functions, and the multiply functions multiple times, you start to realize, I'm glad I have this, because otherwise you have to pass x and y as separate variables each and every time and process them separately, which is easy to wrap your head around when you've got like a few lines of code here and there. But when your program starts to get larger and you're constantly dealing with X and Y at the same time but separately, you start to realize the value of where vectors come into play. And if you want to hear some really great analysis on vectors and the value of them, check out some of Casey Muratori's Handmade Hero series. He's the one that actually got me into vectors and understanding them, and it was that series that got me. I just heard like 10 minutes of him talking about that, talking about them. I thought, oh wow, that's huge. So I definitely recommend that. So that was a data type that we have. And yeah, I mean, I could take you through the whole. I can't take you through. Well, I can't actually take you through every line of code that we have, but you know, for example, here in this test code, when we are looking at the processing some preliminary input, if we see that the input is the action down input, and right now we just have it hard coded to be, and if you look at the actual, I think it's the main loop file, the down arrow key mapped to action down, that's hard coded at this time. But what it'll do is it'll say sprite set direction, and it takes a vector, and the vector we can just use this pound define to pass it right to the function. Otherwise, we'd have to say sprite set direction and then have like an enum, for example, with up, down, left, and right, and then take that enum and then process it accordingly and say, oh, well, if it's down, then add 1 to the y variable and don't do anything with the x variable. But it's nice just to have it all in one place. So that's what we do there. And then we have this massive function called map camera update and render, with a whole bunch of inline helper functions that I just cleaned up a little bit the other day, but probably will continue to evolve over time. And then this is the actual function itself. So we create a series of hash tables, 1, 2, 3, 4 hash tables, which we're going to contain our map, the pixel destinations of our map, the pixel destinations of our background sprites, the pixel destinations of our player level sprites, like the neutral level, whatever you call it. You know, right now it's called sprite pixel dest. Maybe we should call it player sprite pixel dest or something like that, but that's fine. And originally we only had one layer, and so that's why it's just called sprite pixel dest. Maybe we'll just keep it, who knows. And then foreground ones, like the tree, the top of the tree. And what it does is it creates a hash table for all those things, where we will be able to look up what will we be able to do? Oh, we'll be able to look up a sprite by pointer address, and then be able to assign a pixel destination to it, like where it will be drawn on the screen. And then we have, and notice that these are all auto pointers, so they're going to be allocated on the heap, but we don't have to free them manually, so that's pretty nice. And we're going to have the follow sprite pixel destination, if applicable, being handled as a special case. And so then we go through the different processes here of, if we have a follow sprite, we update the follow sprite and get the pixel destination. If the camera was moving, we store that state and we update the move state, and then we figure out if it was moving, and if it was, we do certain things, and if it's not moving now, then we then adjust the corner position of it. And then we have what's called a pixel dest modifier, which basically takes, if the map is scrolling, it's going to scroll in a certain direction opposite to which the direction is that the camera is moving, and the sprites will all have to adjust the same way or the opposite way, depending on what we're doing. And if I thought we had, it's actually in this helper function. What we do is we adjust the camera, and then we see, here's where vectors get useful. We multiply the pixel depth modifier by -1, which just reverses it, which allows us to tells us if the camera was moving a certain way, then move the actual objects the opposite way, but the same amount. And so that's pretty nice. And so anyway, I could just go into this forever and ever, but I only had limited time. I just wanted to start talking about what this looked like. And for those of you who have not seen the work on it thus far, here it is again. What I basically want is, at the end of the day, to have a game that will be local multiplayer. So I want you to be able to have, let's say, 4 players at the same time, between 1 to 4 players, and that could change, but let's just go with that for now. 1 to 4 players who are on a very simple adventure together on a randomly generated map. And I'm thinking that what I'll have is a randomly generated world with a certain number of dungeons, which I think that I will have as a fixed number. So let's say 6 dungeons, randomly dispersed throughout the map. And you have to find the 6 crystals, or whatever the case may be. And then once you've done that, maybe you'll gain access to a final dungeon. I'm not exactly sure how that'll work. And then get the amulet, or whatever the final item will be. And once you've done that, you completed the game. But I want that roguelike nature to be a fundamental part of the game. So you find a scroll, for example, and that scroll, you don't know what it is yet. And so you're able to then either identify it, if you have the right ability to do that, or you just try it, and it might do some great thing, or it might kill you. And if you die, you die. But I'm thinking that the way that I'll do it is, if you have multiple players, if you die, because there's nothing worse in some of these multiplayer RPGs, you're dying and then you have to sit out for the whole game. I'm thinking that if you die, what'll happen is your character will die, and subject to some limitations, or maybe we'll do what NetHack does, which is make a high probability that the items on that character will be cursed. Because if you just allow the items of the deceased character just to be there fully intact, you could just spam the game and just die on purpose, and then collect a whole bunch of swords and sell them or something like that. So I'm not sure what we'll do for that, but we'll figure that out later on down the road. But I'm thinking that if a character as long as all 4 characters, or all player characters, whatever the number is, are not all dead, that if a player dies, they can rejoin the game as a new character who's at level 1. You have to start from the beginning, basically. But you can always catch up to the other character, because you're playing with somebody live. So you can say, hey, you're on dungeon level 20 or whatever. So you can find that other character again. And if you go back and find where your corpse was of the prior character that died, you can collect some of those items. Some of them may be cursed. Some of them may be just no longer available. I'm thinking at least the starter items should be just gone, because that wouldn't be very fair if you could just sell them all off. And then So in that way, you get penalized in the sense that you no longer keep your gold, you no longer keep your experience, but you don't have to sit out of the game, and you're not totally starting from scratch, because you'll still be in the same game as the other players, and although you'll be at a lower level, you'll always have the other player that's still alive to come back to, and maybe you can kind of just help that character and get the final blow on a couple of enemies and then level up quickly again or something like that. So I'm not exactly sure how that'll work, but I think that I don't want to have a situation where a secondary player dies, and then they have to sit out, or they're either no longer included in the game, or they have to sit out for like an hour before the main player can find some like really rare potion, like a pick-me-up, to like revive that character. I just don't think that would be a fun game. I want this to be a fun game. I want this to be a game that you can pick up and play for a couple of hours at a time at the most, and you have maybe if you're really, really good at it, you have like let's call it a 50 to 75% chance of beating it. And if you're really new at it, you have like a low chance of beating it, but like it's possible. But I don't want it to be one of those games, like, although it would be highly influenced by NetHack, which is one of my favorite games. I don't want it to be one of those games that it's almost impossible to win. Like, I want there to be that fighting chance, and then if you win, you win, and it's not a huge accomplishment. Like, you just have to play again, and maybe the next time will be a bigger challenge, or whatever the case may be. But yeah, I don't want this to be like, fun will always be the primary factor. If it's like, well, this is like a more challenging mechanic, or this is like a more, fair mechanic even, but it's not fun, it's just not going to be included. The game has to be fun. I want people to be able to pick it up and play it together and have a good time. And I definitely want there to be that sort of local co-op feeling of like, you're working together to beat the game. What's the word I'm looking for though? Like, to complete your quest, you're working together. And there's a long way to go still as to how this will all fit together. But if I can't get the basic engine done, then we're not going to get anywhere. So that will be something that we'll continue to work on. But it's been challenging thus far, but it's been fun. You can even attack the tree. I think I told you that before. But I've honestly had a lot of fun just walking around and just attacking these enemies that, there's not going to be any consequence to doing so. There's no concept of HP yet in the game, anything like that. But I'm still having fun just walking around whacking these enemies, and that's something I kind of want to. Like, if people can just wander around for an hour and just fight things and have a good time, and then just say, I've had enough of this game for today, and quit the game, and then maybe try again the next day in a new adventure, fine. That's all I really want. I just want this to be a fun game. And I want it to be, every time you play it is a bit different. And yeah, I'm thinking I'm just going to have a couple of character classes, nothing too much. Like a fighter, a mage, and an archer. Like, I'm probably just going to follow in these sprite sheets that I have, but definitely a fighter and a mage. And I feel like there should at least be one other character class, but I want the two basic choices to be, are you a character that specializes in physical attacks, or are you a character that specializes in magic? And I think that those are the two fundamental things that we want to focus on for this game. Yeah, and I'm also not sure how it will work in terms of, like, let's say, like I said before, we have 6 dungeons that are accessible through the world map. I think I probably do want the ability for, like, player 1 is in a totally different dungeon than player 2, if that's the way they choose to do it. But I'm thinking that you will not be able to have any interaction, like, except maybe with a few very specialized spells or scrolls. If you're using basic items like a potion or a basic spell, like a heal spell that has to be within a certain range, I only want it to work on another player if that player's in the same camera as you, in the same screen, basically. So if the 2 players are cooperating, then it provides the advantage of being able to, like, you can heal the other player, you can give them an item. That's another thing too. Again, except with like a specialized scroll or spell. I don't want players to be able to transfer items to other players unless they're physically on the same screen. So let's say you got this guy right here who has like 10 potions, and then player 2 has 0 potions, but has like a really great sword that this fighter could use. I want player 2 to be able to join this screen, and then player 1 can give player 2 some of the potions, and player 2 can give player 1 the sword. Like, I'm not talking complicated stuff here, I'm just talking basic mechanics. I think would be a lot of fun. And yeah, that's basically where we're at. So, I think I will sign off. I don't think anybody joined me today, and if they did, I don't think anybody had any questions for me, but that's okay. Maybe we'll try this again another time. Appreciate anybody who was watching. If there was anybody, cool. If not, then maybe next time. Thanks again. This is LA Rathbone signing off. Have a good day.